Another important point, that is the third phase of the rocket will be ignited again, and then it will be the transfer orbit of the lunar orbiter Chang'e 2.
长江3号跟踪正常，遥测信号正常。长江3号跟踪正常，遥测信号正常，北京飞行正常。
So the second powerful phase for the third stage is around 2.5 minutes.
It lasts 2.5 minutes.
2.5 minutes.
You mean when the third
engine
stage is ignited?
So the flight altitude is about 118 kilometers.
Do we have a ratio of distribution of the propellants in different stages?
You mean the
propellants in the first stage, the second stage?
It's the same.
Is the same.
Right.
And if the composition is the same.
The proportion of fuel to oxidizer is the same, yes. The actual mass of fuel in each stage is roughly a factor 3 or 4 less than in the previous stage. Depends on the rocket and the mission.
You can see the ignition of the third stage.
You mean the ignition has already started?
And now seconds.
Well, the ignition started.
Right.
So the cold phase is passed. The third stage, the ignition of the third stage has already started. That's a successful ignition. And that means we are about to embark on the Earth to Moon transfer orbit, which is one of the key points this time for this mission. That is until 2 minutes away, we will know whether or not the major mission of lunar orbiter Chang'e 2 is successful, because by then we will know it is on its trajectory or not.
Right.
So next action is the separation.
The separation from the rocket.
Right. It's it's a key element, a key point.
So when it separates from the rocket, then it's relying on itself for power. How different is this power from the rocket power when the orbiter or the spacecraft is on its own?
The spacecraft is relying on its own electrical power at this time. The only power it's getting from the booster is that the booster is pushing it.
Why don't we have booster all the time to have power? Why we have another source of power for the spacecraft?
It only takes a few minutes to use up all the fuel.
So we have to have a sustained way of power.
Yeah. There's also another principle, which is that if you have a chemical rocket engine in a low orbit around the Earth and you fire it very quickly, use all your fuel in 5 minutes, then you can produce a certain speed for the spacecraft. But if you burn the fuel very slowly, then what you're doing is you're spending a lot of the energy of that fuel lifting fuel to higher altitudes, and it's actually less efficient.
And from ground to orbit, a lot of fuel will add a lot of weight, burden on the liftoff process itself.
A lot of fuel has to be spent lifting everything up to the top of the atmosphere. Yes.
So that is why the fuel has to be spent very quickly in the liftoff stage.
That's right.
And when it is on the way to the outer space, it has to spend slowly.
If the thrust of the rocket is twice the weight of the rocket, then it will accelerate upward at 1 Earth gravity. Okay. On the other hand, if the thrust of the rocket